Welcome to Modular Learning channel. My name is Learning-WHu. Today we will talk about Inter-Vlan routing. VLANs are associated with subnetworks, like VLAN 10 is associated with subnet 172.16.10.0/24. So PCs in this VLAN will get IP address from this subnet. And VLAN 20 is associated with 172.16.20.0/24. Network devices in different VLAN, like PC4 and PC5, won't be able to communicate without a router at this moment. The VLAN basically isolates the communication between different VLANs. Unless we have a router that provides routing between the two VLANs. So when a PC in one VLAN, like PC4, needs to talk to PC5 in different VLAN, VLAN 20, a router or a layer 3 switch is required to provide inter-VLAN routing. Now, let's look at the legacy inter-VLAN routing solution. Two VLANs, VLAN 10, VLAN 20, are created on this switch. So in order to enable the communication between PC4 and PC5 in different VLAN, we need a router. Then we also need two links between switch and the router. The left side link is the link for VLAN 10 traffic going up from the PC to the router VLAN 10 interface. The right side link is for VLAN 20 traffic. So this is exactly like interconnected to subnetwork using a router. And in this way, we are implementing the inter-VLAN routing using router. But obviously, this solution is not scalable because we need one link for each VLAN. As the number of VLANs increases, we need to increase the routing interfaces, one routing interface per VLAN, in order to enable the inter-VLAN routing. Then this is the problem. We need too many routing interfaces to support many VLANs, not scalable. A trunk link between router and the switch that support traffic from multiple VLANs over the trunk. So a single physical link will be able to support as many VLANs as needed. That becomes scalable with the trunking protocol. So how does the trunk work? We use 802.1q trunking protocol. This trunking protocol basically insert tag in the original Ethernet frame. So, for example, PC4 sent frame to PC6. Then the frame will go up to the router through the trunk. Before switch 3 places the frame on the trunk, switch 3 will insert a VLAN ID as a tag in the original Ethernet frame. Then that tag identifies the VLAN membership. So the router on the other end receives this tagged frame, will be able to place this frame on the VLAN 10 subinterface based on the tag in the frame. This is the tagging strategy. So then the router will route the frame from subinterface F00.10 to VLAN 20 subinterface F00.20. Then the router again is going to tag the frame before place the frame over the trunk. This time, the frame tag is VLAN 20 because that's the destination the frame is heading to. Then the switch receives this tagged frame. Based on the VLAN tag 20, it will place the original Ethernet frame over the correct VLAN towards PC6. Before placing this frame over the trunk, the source switch will insert a 4 bytes VLAN tag. Then the 4 bytes VLAN tag use 12 bits indicates the VLAN number. So if this frame comes from VLAN 10, the VLAN ID would be 10. So the destination device, like the router, will be able to read the tag and remove the tag, place this frame, original frame, on the correct subinterface associated with the original VLAN. I'm going to use this packet tracer to show you the route-on-astick Inter-Vlan routing solution. We got a trunk, interconnect the switch, and the router. Then we'll create 2 VLANs, PC4 in VLAN 10, PC6 in VLAN 20. Let's see how do we configure this Inter-Vlan solution. First, we go to switch and create 2 VLANs, VLAN 10, name it like student, and VLAN 20, name instructor. Then we're going to assign ports to these 2 VLANs. So I'm going to assign VLAN 10 interface F010 and put this port, switch port, mode access. So configure this port as the VLAN access port. Then switch port access VLAN 10. Similarly, go to port 20. Configure port 20 to access VLAN 20. Okay, after this, we're going to configure the trunk, which I use port 1. And so simply go to interface, FA01, switch port, mode, trunk. Finished the switch configuration. We got 2 VLANs, and the PC4 is connected to port 10, which belong to VLAN 10. So let's verify the VLAN configuration on this switch. Show VLAN, brief, 2 VLANs, VLAN 10, student VLAN. The port in this VLAN is 010. Instructor VLAN, port 20 is in this VLAN. And so PC4 is on VLAN 10, 6 is on VLAN 20. Check the trunk, interface trunk. Port 1 is configured as trunk. 802.1q is the trunking protocol. And the native VLAN is default 1. Switch is ready. Then this trunking protocol needs to be configured on the router as well. Then router will be using the sub-interface, one sub-interface for each VLAN. So we need 2 sub-interfaces. F0/0.10 is the sub-interface created for VLAN 10. Then we can give IP address on the sub-interface. That IP address acts as the default gateway for PC in VLAN 10. So let's go to the router. Configure the router sub-interface. So interface F00, that is the physical interface. We only need to do on this physical interface is no shutdown. Then the actual IP address we configure on the sub-interface, interface F00.10, and the sub-interface number 10 is arbitrary. You can choose any number, but for consistency, I'm going to choose .10 for VLAN 10, .20 for VLAN 20. Okay, and now we need to define the 802.1q tag number. We're going to tag any traffic on this interface with the VLAN ID 10. So encapsulation, give the VLAN ID 10. Okay, and the same configure VLAN 20 interface, VLAN 20 encapsulation .20. Now configure IP address. VLAN 20 interface, we're going to use the IP address from 172.16.20.1/24. That is the IP address configured on the sub-interface .20. This IP acts as default gateway for PCs in VLAN 20. So we're going to configure the IP address for interface F00.10 as well. IP address is going to be 10.1. Okay, now we are done. The sub-interface configuration. Both VLANs are having the default gateway pointing to the sub-interface. Let's double check the results. IP interface brief. Now you can see the 2 sub-interfaces are configured. One for each VLAN, act as default gateway. Now PC I have already configured. So with this sub-interface created, if we check the routing table on router, we can see 2 subnetworks already connected to the router, one on each sub-interface. The router will be able to route the packets between these 2 subnetworks. The subnetworks are associated with the VLANs. So this is ready to route. Let's check the communication. PC on VLAN 10 is having IP address 172.16.10.10 default gateway, 172.16.10.1, which is the IP on the sub-interface 10. I'm going to ping this PC on the right side, IP address 172.16.20.20. Let's ping. So just to show you, the IP address on the left side PC is 172.16.10.10. Default gateway pointing to the sub interface 10.1, and I'm going to ping here, ping 172.16.20.20, which is PC on the right side on VLAN 20, and it's successful. So Inter-Vlan routing using route-on-the-stick solution is configured. Okay, so let's look at the summary. Since it's scalable using a trunk, we can add any VLAN we need. Then the trunk link doesn't need to be changed. Still need only one physical link that can easily support as many VLANs as needed. But there are some drawbacks using this route-on-astick. First, there is a single path for all traffic from all VLANs. Then this link between switch and the router can get congested and causing delay. And another drawback is single point of failure. If this link failed, or if the router failed, inter-VLAN communication would fail. So the solution is using a layer 3 switch to do the inter-VLAN routing. Similar scenario, we got two VLANs. Instead of using router, we use a layer 3 switch. Layer 3 switch is actually a combination of a router and a switch. You can see the icon has a ball in the middle that representing the routing function. So layer 3 switch can do the routing. How does layer 3 switch perform the routing? It uses the switch virtual interface SVI. The SVI is associated with the VLAN or connected to the VLAN. We basically create a switch virtual interface for each VLAN, then give IP address like 172.16.10.1. That IP address on VLAN 10 interface acts as the default gateway for device in VLAN 10. As I said, layer 3 switch has routing function. Once we enable the routing, the layer 3 switch will be able to route the packets from VLAN 10 interface to VLAN 20 interface via switch virtual interface SVIs. And the link between the layer 3 switch and the layer 2 switch must be a trunk. So that trunk link will support traffic from all different VLANs flowing through this single physical link. This is the layer 3 inter-VLAN routing solution. On the left side is exactly a similar scenario like route-on-astick, but now we replace the router with a multi-layer switch, and the switch under the multi-layer switch has been configured. Two VLANs are created. Show VLAN brief. We can see the two VLANs we created like before, right? And we assigned the port F010 to be a member of VLAN 10, and port F020 is VLAN 20 member. PC is already connected. And again, we got port 1 configured as a trunk. So port 1 is trunk port, which connect up to multi-layer switch. Let's create two VLANs first, a multi-layer switch. VLAN 10, name, student, VLAN 20, name, instructor. Now, on this layer 3, we only need to configure trunk F01. Okay, F01 is the trunking port, so switch port, mode, trunk. Multi-layer switch support more than one trunking protocol, so I need to select the trunking protocol .1Q first. Switch port to trunk, encapsulation, .1Q, .1Q. Okay, and then I can say switch port mode trunk. Now, trunk is configured, verified, show interface trunk. FA01 is a trunk port, native VLAN 1, mode on, ready. And now, if I ping right now, the ping between the two PCs will fail because the multi-layer switch routing function has been disabled by default. If I check routing table, show IP route on layer 3 switch, currently there is no routing table. So I needed to enable routing function type IP routing. Okay, after this, but the VLAN interface has not been created. You can see the interface. There is only one VLAN 1 interface. So let's go. Interface VLAN 10. This is the SVI I created. Now VLAN 10 interface is up right after I created. I needed to put the IP address on this interface, which is 172.16.1.255.255.255.0. This IP on VLAN interface 10 is the default gateway for PC on VLAN 10. Same, I'm going to go to interface VLAN 20 to create VLAN 20 interface. Now, VLAN 20 interface is up. IP address. Okay. Now double check. Show IP into brief. We see the two VLAN interfaces are created: VLAN 10 and VLAN 20. IP address 10.1 is the default gateway for VLAN 10. 172.16.20.1 is the default gateway for VLAN 20. Ready to go. PC already configured with IP address. And then I'm going to ping from left side PC to right side PC. IP address of the destination is 20.20. So let's try. Ping 20.20. When I ping, the traffic, see, it's successful. When I ping, PC4 sent Ethernet frame to the switch. Layer 2 switch 3 will insert .1Q tag. Indicates this frame comes from VLAN 10. Send over the trunk to layer 3 switch. Layer 3 switch look at the tag realize this frame belongs to VLAN 10, so it receives this frame on VLAN 10 interface. Then multi-layer switch look at the destination, is heading to VLAN 20. So it's going to route the packets from VLAN 10 interface to VLAN 20 interface and insert a tag, which is the destination VLAN, VLAN 20. Send the tagged frame over trunk. When switch 3 receives this tagged frame, based on the tag VLAN 20, switch 3 will place the frame on the correct VLAN link, reach the destination. This is the layer 3 Inter-Vlan routing solution. So if we look at the routing table on layer 3 switch right now, show IP route, you will see that layer 3 switch has a routing table that has two subnetworks interconnected via VLAN interface, VLAN 10, and route to VLAN 20 interface between these two routing entries. Now, we demonstrated the two Inter-Vlan routing solutions, route-on-astick and layer 3 switch. Thanks for watching.